Good morning. I'm here to talk today about using Power BI to report on your OS deployment build statistics. My name is Mike Marable. I've been with Michigan Medicine, formerly the University of Michigan Health System, for a little north of 13 years. I've been the OS deployment architect there that whole time. Here I'll have my contact information. If you have any questions, feel free to email me. I'll do my best to answer them as best I can. All of the material for this presentation is available on a GitHub repository I've created. I'll list it down there at the bottom of the slide there. So this presentation will be broken down into three main sections. First off, why would you want to do this? Second, once you've decided, yes, you do want to do it, how do you go about collecting the data? And then finally, once you have the data, how are you going to go about presenting it? So first off, that's the first question. Why would you want to do this? Well, I'm sure many people who are responsible for the OS deployment task sequences in their environment have at one time or another or multiple times had essentially the stability or the quality of their work called into question. You know, a manager heard through the grapevine that the build fails all the time, or it takes forever and hours and hours and hours, or this, that, and the other thing. And they're, essentially called into having to defend their work. Excuse me. I've had a number of those conversations, and I finally decided that I needed to stop being reactive to these things and needed to be proactive. So I created this. It's a Power BI dashboard. The first iteration of this was not in Power BI. From that, when I first started this about two and a half years ago, I was just collecting information about build success and failures and build times. I was collecting that in a CSV file, pulling it into Excel and using some simple Excel charts to present the information. And over time it grew as I started finding more things that I could report on. There are a number of ways you can get from nothing to this. You could query directly against the SCCM database. And in fact, there are a number of people that have created Power BI dashboards that do exactly that thing. Like I said, when I started this, it was much more, my aspirations were much simpler. I was just looking at, like I said, success rates and build times. So I was pulling that information directly at the completion of a task sequence. And over time, like I said, I began to expand upon it. And I was pulling task sequence variables out. In my environment, like I said, we're a 1E shop. So we have, using the custom settings INI file, we determine based upon the default gateway, if a machine is in a remote site, which would require the use of Nomad, or if it's on our main campus network, which would not. So I have information, that query sets a task sequence variable. I collect that task sequence variable, and therefore I'm able to tell exactly how many builds are happening on the main network and how many are happening in slow sites. We have a front end, an HTA front end that the build tech would step through. One of the options they have in there is determining whether they want to use USMT to back up and or restore the data. Again, those are task sequence variables. I collect those and I'm able to tell you exactly how many machines how many builds use USMT to back up and or restore the data. Pretty simple. Like I said, that's the whole goal in this is a simple process. So over the time, like I said, I started with pretty simple, and I would start adding different things that I would report upon. So I can tell you, failure reasons, the top 10 failure reasons, why builds are failing, that sort of thing. I can tell you how many builds are happening per day, how many builds are happening per different revision of the build sequence. And like I said, originally it started with Excel. Over time, I moved to Tableau, still using the same CSV data files. And then moving from Tableau up to Power BI. For this presentation, I created this real simple Power BI dashboard. It leverages sample data that I also included up on the GitHub repository, as well as the template for this Power BI dashboard. Collecting basic information, failure rates, failure reasons. I mimic the same sort of thing, whether they're in a fast site or a slow site, build times, that sort of thing. So again, This Power BI template, as well as the sample data file, the CSV file used to create this, are available on that GitHub repository. So if you decided, yes, you want to do this, how do you go about collecting that information? Well, like I said, keeping it simple, I collect task sequence variables at the completion of the build. What you would want to collect is going to be based upon what's important to you in your environment. Like I said, in our environment, we have the wizard, where you have the options for USMT. We have fast sites, slow sites. That's our environment. Every environment is going to be different. Where to collect it? Pretty simple. Push it up to CSV files onto a file share. Very simple. And how to collect it? Well, at the completion of the build, for this presentation, I use a PowerShell script. And that PowerShell script is available on GitHub. But you could use anything. You could use VB script, you could use JavaScript, you could use a batch file if you wanted to. Since we're running to a CSV file, keeping it simple, anything that writes to a text file would work just fine. First thing you got to do is you have to structure your task sequence to avoid this. And not just avoiding a failure, because you're going to have a failure at some point. You don't want to, when a failure happens, you don't want to just pop this message and be done with it. What you want to do is you're going to want to structure your task sequence so that you can capture a failure and exit the task sequence in a controlled manner. And I'll show you how you can do that here in a second. Excuse me. Now, for years, I was using a very simple logic but cumbersome structure in my task sequence to do that. And at the completion of every action, the task sequence engine will assign a variable SMS TS last action succeeded, a true or false based upon the success or failure of the action. In the structure of my sequence, I would have the main group, which would be set to continue on error. So if a failure happened, the task sequence engine would work its way back up to the main group, continue on error, would then drop down to either a failure group or a success group. And if SNSTS last action succeeded was false, meaning it was a failure, it would fall into the failure group. It was set to true, it would fall into the success group. The problem I would run into every now and then would be if you fell into the success group and something failed, it would then trigger that and you would stumble into the failure group. So before the holidays, Adam Gross, who writes the blog A Square Dozen, came up with a much structurally sound way of doing it. And I've made the switch over to using that, his logic behind it. And it breaks it down into the try-catch finally. You got your main group, the try block. This is where all of the heavy lifting of your task sequence is going to fall into. Again, the main group is going to be set to continue on error. So if you have a failure, everything flows on up, and it would, the task sequence itself will continue on down into the failure group. The difference being, in his, the step here, set TS variable to all steps succeeded. Now you can call that anything you want. You can call it all steps succeeded. You can call it finish line. You can call it successful build. All that's going to do is that's going to be the variable that would trigger running the success group and the catch blocks, which I'm going to do in a moment. The important point here is that you have two different variables independent of each other, controlling whether you would fall into the failure group or you would fall into the success group, which is a big improvement over the method I had been using for years. So after the try block, you have the catch blocks. You have the failure group, which in this case will be triggered if still SMSTS last action succeeded is set to false. So if you have a failure, you flow up the main group drops you down to failure group, the condition is met, and you execute the steps in the failure group. Success group in this case is only executed if that variable all steps succeeded is set to true. So you don't accidentally stumble one into the other. And then lastly, success or failure, you have the finally block, which will be executed regardless of the success or failure of the task sequence. Here's the bulk of the actual logging that will happen. Now this task sequence, like the sample files and everything else is available on the GitHub repository, so you can import it into your environment if you want to test it out. I'm not going to go through the whole task sequence because deploying an OS, that's pretty common. Everybody knows how to do that. I'm going to focus on what's directly relevant to tracking the build stats. At the beginning of my main group, I have a small block where I'm setting 3 variables for this case. First, OSD version. That's simply versioning of the task sequence. This will be used by the script to change the name of the CSV file to match what version of the task sequence it runs. This way, version 1 is separate from version 2, is separate from version 3. OSD branch. This I have set for demo for the demo purposes, but in my environment that would be set to either dev when I'm doing development work on a new revision, QA when that version is ready to go off to QA testing. When QA testing is finished, I would switch it to pilot, and I would then switch it to production when it goes to production. This translates into a folder, keeping dev work separate from production work, and so on. And then lastly, the record build start time. This is starting the stopwatch. This is a PowerShell one-liner. It just sets a variable called OSD start info to the date and time that essentially the task sequence starts. The catch blocks. These are pretty simple. There's 2 of them. The failure group would be run if that SMSTS last action succeeded is set to false. And I'm going to set a couple of task sequence variables. The important ones here, if you're using Config Manager 1810, the SMSTS last action name is new. So if in case you have a failure, you fall into this, the last action name would be the name of the action that had failed. So I assign that to a new variable called failed step name. The script would then use this if in the case of a failure to record the failure reason. The other important one in this case, all steps succeeded, I set that to false. That's just to reinforce, preventing us from unintentionally running the success group. This OSD results variable. This will be passed as a parameter to the PowerShell script, and it will tell the PowerShell script to record either success recordings or record it as a failure, meaning essentially pulling in that failure reason. And I have the matching one in the success group. In the success group, that would execute only if that all steps succeeded is set to true. And in this case, all I'm doing is setting the variable for the OSD results to pass to the task sequence. The finally block. This is where, like I said, the bulk of all the logging happens. Using a lot of task sequence variables because it's easier if you have to change something to change it once in a variable as opposed to having to go through finding it in multiple locations in their task sequence and then finding it in the scripts and things like that. So I leverage task sequences an awful lot. Task sequence variables an awful lot. First one I said is what server am I going to log to? My lab, it's FSO1. It's just a simple file server. This is used to build out the OSD results share variable. In this case, it will be FSO1 from the log server variable, MiSCUG for this particular demo. I use my network access account to access the share defined by that variable. And then I run the PowerShell script, and I'm passing it the variable OSD results, which would either be success or failure. That then triggers in this PowerShell script whether it would just, for the failure reason, if it'll record the failed action name for the failure reason, or if it just listed as success. The PowerShell script is pretty straightforward, and it's available on the GitHub. If it will collect just the task sequence variables I've defined. In this case, things like the task sequence ID, the task sequence name. It'll take the start time, and then in the PowerShell script, it'll pull the current date and time, and between those two, it'll calculate out the number of minutes that have elapsed. It'll record the computer name, the model of the computer, what the variables for the USMT backup and restore were set to. Things of that nature. And after running the PowerShell script, it disconnects from the the OSD results share. And that's the completion of the task sequence. On that share, in this case, I have 2 files out there. The OSD results tally 00. That's the sample file. There's about 490 plus sample build records in there. Various makes and models, various failures. There's some failures, there's some successes, various failure reasons, varying dates, build times, things of that nature. So it'll give you a decent spectrum. The OSD results tally 30. That's the one I've run a couple of test builds for the demo here. And you can see a screenshot of the data that's recorded in there. So next one here, there's like the first 25 records of that 490 plus sample file. And you can see there's all sorts of varying build times, different makes and models, successes and failures, and different failure reasons that have popped in there. All right, so you have your data. Next question is going to be, how are you going to go ahead and report that information? Well, you're going to start with Power BI. Now, Power BI, you're going to recognize, pretty familiar with the typical office layout. You got your standard ribbon bar. Visualizations here, these are all the various graphs and chart types you have available. And this field section, which right now is blank because I've not pulled in any data, once you pull it in there, you'll see fields that correspond to your column headings of the CSV. How do you go about pulling in the data? You get data. And one of the great things about Power BI is you just have a huge spectrum of various sources that you can pull data from, all sorts of database formats, just about everything under the sun. Now you could specify you want to pull from the CSV because you recorded it to a CSV. You don't want to do this because, like I said, in the script, each revision of the task sequence will generate a new CSV file. If you specify CSV here, you're going to point it to a single CSV file, and then anytime you generate a new one, you have to go back in and add it. Instead, you select folder, and what it'll do is it'll go out, it'll ask you what folder you want to pop it into. And in my case, it's just my file server 1, MiSCUG folder. And just browse down to my demo. It'll go out to that folder, it'll find what files it has. And first it's going to give me a list of the files that it found. This way, if you have an errant file in there that would throw things off, a README file or an older sample file that has different column layouts, something that you don't want to throw things off, it'll at least give you the opportunity to catch that. But this looks fine because I only have the 2 CSV files. Combine and load them. Next, it'll present me a table of, here's the data layout that it's found. Again, it's to help you catch, okay, let's say you have your column headings off. So if you see here that instead of start date times, you have your task sequence IDs, it gives you, a warning to fix it before you pull it in there. But everything looks great. Hit OK, and what it's going to do, it's going to go out, it's going to pull that data into its own internal data table. And you'll see the field headings over here on the far side of the screen begin to populate. Boom. All right, at this point, it's all clicking and dragging. So the first, most basic one is, what's the success rate of your builds? Well, that's easy enough to do in a pie chart, which I have something set up over in here. Simple, select a pie chart. We'll enlarge it to make it a little easier to see. Now these fields down here will change depending on what type of chart type you select. For a pie chart, we're interested in two fields, the values and the legend. Well, our success failure rates are recorded in the OSD results. So if we just click and drag that over here to values, it'll total up everything. We get one single solid pie chart. Why is that? Because we've not told it based on that legends field of how to break it down. Take OSD results and drag it into legend. It'll split up the numbers based on success and failures. That's great. The colors don't seem to really match what a success failure rate might be. To customize the different charts, you just click on this icon over here for the, looks like the paint roller. And here you can turn legends on, everything that's available to customize the different charts that's available to you. Failures are usually red. Data labels. They're awfully tiny here, but we got a success and failure. Those are the data labels. Let's make them a little darker. Let's blow them up a little bigger so you can see them. So the label style, we have a couple of options. Category, that's what's being displayed right now. That's the actual data that I found in there. In this case, success and failure, because those are the only two that are found in that column. Data value, that's all going to total up success and failures. 460 successes, 39 failures. And of course, you got percentage of total. And you can do various combinations of them. I'll just throw all of them in there. So it shows you had 460 successes, or a 92% success rate. So far, so good, pretty good. We'll shrink this down off to the side for the next one. Build times. Well, in the sample one, I just have these little cards that show the build time information. It's easy enough to do that as a card. Card is a simple little thing. It's just a little dialog box that reflects one particular data element. Now, the PowerShell script will automatically calculate out your elapsed time. So, whereas in the pie chart we had a number of fields we had to worry about, since a card just displays one bit of information, we just got the one field. We'll just drag the elapsed time, drop it in there. Totals up about 45,000. That doesn't sound right. If you click the little down arrow next to the elapsed time, you'll see that it summarized the entire thing. So it totaled up all the elapsed times, which is not what we want. We're looking for the average. What we do is click average, and we get about a 90-minute average build time. Now, just like any other Office type app, you can click and copy these things. So that one's the elapsed, or the average. What's the longest? Select maximum. So the longest is about 1,200 minutes. Shortest build time, choose minimum, about 11 minutes. Pretty simple and straightforward. Failure reason, that's the next good one. Down here in the sample chart. It's called a fan chart. So I'm going to click on the fan or funnel. I'll make it a little bigger. And similar to the pie chart, we have the data we want to actually present and how we're going to group it. So failure reason, that's pulling the actual name of the task sequence action that failed. If we drop it into values, just like in the pie chart, it just totaled up everything. Because if we drag the same thing into the group, it defines how we wanted to split it all up. So far, so good, except success is far outweigh everything else. It overwhelms everything else in the chart. That's where a filter would come in. Filters are used to do exactly that, filter what information is going to be displayed. And you have three types of filters in a Power BI report. You have the visual level filter, which affects this one visual. You have a page level filter, which affects everything that would be on this page. So let's say you had a chart, you can have multiple pages. Let's say you have a page devoted to just statistics on failures. Well, you can filter out successes, and every chart you put on there would only be reflecting of failures. Or let's say you wanted to show bill statistics based purely upon machines that are built in slow sites. Well, you can use that fast site, slow site that I have in here, which would be this one. You can filter the entire page to show just slow site equals true. So that every chart you put on there would only reflect those machines that are built in your remote sites. And then the report level filter would affect everything. So let's say you have multiple builds. You have a version 7 or a Win 7 and a Win 10. Although those are being recorded to the same CSV file, well, you want this report to only show, let's say, Windows 10. But you can just set a report level filter based upon, something within the task sequence name, for example. But for this chart, I want to filter out all of the successes. So instead of cherry picking these here, just hit advanced filtering and show me everything that is not success. Apply that filter, and it's just going to show the failures. And you can do the same thing. You can change, again, failures are usually better displayed as red, and you have all the same sort of things. You can change the title, you can change background colors, the size of the text here. So you decide the funnel chart's not really what you want to use. All you got to do is just change it to a bar chart. Click on the bar chart. Power BI will retain all of your customizations, all of your configuration, and just change the structure of the chart. So you can just pop it into all sorts of different chart types. Maybe a donut chart would better show it. Pie charts, It's one of the cool things. You can change your chart information without having to go through and restructure the whole thing and recreate it all from scratch. So when you have your chart all set, your report all set, you can publish it and like we display it on our SharePoint site. So if there's ever any kind of questions about, how long does the bill take? Well, the information is right there on the SharePoint. Does anybody have any questions? Thank you very much.